Okay, the next problem we are going to see in statistical analysis. From the previous video, only one problem we have solved. Now we are going to solve the another problem, but the problem is different from the first one. Here they have given so many frequency of occurrence, but the interval was not mentioned in the previous problem. That was the difference. So here when you are looking in your test, temperature is measured 100 times with variation in apparatus and the procedure after applying the correction. So here in the question itself they have given the total frequency of occurrence. The value is 100. So out of this we are going to calculate arithmetic mean, mean deviation, standard deviation, probable error of one reading, standard deviation and probable error of the mean, then standard deviation of the standard deviation. So in this problem they have given the temperature and the frequency of occurrence. So what we supposed to do is, first we have to tabulate the temperature differently, then we have a frequency of occurrence, then out of which we have to calculate the mean deviation, standard deviation. So if the frequency of occurrence is given, you have to calculate. The first step is you have to multiply the temperature with the frequency of occurrence, that is T into F. So T into F, for the first value 397 into 1, you will have 397. Likewise, we have to multiply each temperature with the frequency of occurrence. After multiplying the temperature and the frequency of occurrence, you have to calculate the total, that means summation value. So for frequency of occurrence, the total value is 100. Multiplication of T into F, you will have 40078. After that, we have to calculate the deviation. So the deviation 1, which is nothing but x minus x bar. After calculating the deviation, you have to calculate the frequency into deviation. So frequency into the deviation value. After calculating the individual thing, you have to summation, that means summation of modulus of f into d. So summation of modulus of f into d will give you 102.8. Then you have to calculate the deviation square. So you have to square out the deviation value. So when you are squaring the first value, that is 3.78, you will get 14.28. Then you have to calculate the frequency into d squared. That is because of you have to calculate the standard deviation. For that reason, we are multiplying the f into d square. So if you are multiplying f into d square, you will have the first one is 14.28. Next one, 7.72 into 3, you will have 23.18. And the third value, likewise you have to calculate the thing. Then out of this f into d square, you have to calculate summation fd square. So the total value we have reached 191.08. So that is how for frequency of occurrence we have to calculate. So you should not forget while calculation of T into F, F into D, F into D square. That is very, very important if the problem is given a frequency of occurrence. Then from that we have to calculate the mean temperature. So mean temperature, you are having here that summation 1 is T into F. So you will have 407.8 by 100. The 100 is in sample. So you will have 400.78. Then mean deviation, which is nothing but calculate the value of f into d summation. So summation of f into d, you got 102.8. So 102.8 divided by 100, it will give you 1.028 degrees centigrade. Then standard deviation sigma, that is nothing but your summation d squared f into d squared divided by your number of sample. So here the formula used is root of summation d squared divided by n. So you'll have sigma, which is 1.380. Probable error 0.6745 into sigma value. So 0.6745 into 1.380 will give you 0.93. Then probable error of mean, which is nothing but the probable error, what you got it, that value multiplied with root n. So you'll have 0.093. Then standard deviation of the mean is Z sigma m, which is equal to 1.38. That is your standard deviation by root n. It will give you 0.138. Then standard deviation of standard deviation sigma sigma, which is equal to sigma m by root 2. So that will give you 0.138 by root 2. So the value is 0.0796 degrees centigrade. So if the frequency of occurrence, frequency of interval is given in the problem, you have to calculate in this way. This is the way of calculating the statistical analysis of data. Okay. And the next one is, I would like to tell you what is your uncertainty. The uncertainty PDF was already sent. So how we are going to calculate the uncertainty, and you should know the difference between the uncertainty and the error. So error, which is nothing but difference between the measured and the true value. So measured one, we used to have the letter is AM and the true value is AT. So while you are subtracting, AM minus AT will give you the error. How will you calculate percentage of error? That is nothing but AM minus AT by 80 into 100. AM is measured, AT is true value. So while you are subtracting those two, you can able to calculate the error value. What is uncertainty? Uncertainty, which is nothing but a quantification of your doubt. So we can't able to tell you the correct value. So we'll have some prediction. That is what uncertainty talks about. So uncertainty, which is nothing but a quantification of the doubt about the measurement result. So how we can calculate? That is nothing but measurement, which is equal to best estimate plus or minus uncertainty. So which is nothing but, here you can look through this. We are having the problem x, which is equal to x bar of plus or minus of w of p to 1. So here this x bar is the reading. This is your uncertainty interval and odds. So this is based on the opinion. So the value will have theta, which is equal to 100 degree plus or minus 1 degree. So this is the amplitude value. This is the magnitude value plus or minus your uncertainty. So always the uncertainty, which is because of the error, that is nothing but bias as well as the systematic error. Only because of those two character, those two error value, the uncertainty will present. So uncertainty is always represented like theta, which is equal to magnitude plus or minus of your uncertainty. So here the example is 100 plus or minus 1 degree centigrade. So how we can say the theta, which is nothing but either it is 101. 101 means 100 plus 1, or it is 99. So your value is lies between 99 to 101. Between these value, either it is 99.1 or 99.9 or 99.0 or 99.3. So many possibility of values will come. This is how the uncertainty value is going to calculate it. 100 plus 1 gives 101. 100 minus 1 give you 99. So your range lies between 99 to 101. So the unpredictable value, the error may be between the value of 99 to 101. We can't able to tell the correct thing. Either the possibility of 99 point something, likewise it will false. That is what uncertainty talks about. So while you are doing this uncertainty, how it came? Uncertainty is because of incomplete definition of the quantity under measurement. Incomplete definition of quantity under measurement, or because of withdrawal conditions or storage condition, or because of the error, that is I already told you, systematic error. And one more thing is unrepresentative sampling. That means they can't able to, this is what they can't able to predict. So that is what the uncertainty talks about. It's all like a doubt, maybe like this, or maybe may not, maybe it will fall this particular limit, or else it will exceed this limit. Some doubts happening, no? That is what the uncertainty talks about. This is what your uncertainty term in your measurement system. Thank you.